Mastering data cleaning techniques. Only a handful of data quality experts can separate signal from noise in a chaotic sea of dirty data. Who among data quality experts and professionals can explain the most common data cleaning techniques employed in various industries, and how they distinguish themselves from one another in terms of their applications, strengths, and weaknesses? The subtle art of data cleaning techniques. It's a world where the unseen determines the scene, where the messy becomes meaningful, and where the detective in us revels in the thrill of the chase. As I delved into the realm of operational excellence, I found myself entwined in a dance of sort and filter, navigate and discover, and iterate and refine. Let me take you back to a particularly memorable project I worked on, where a prominent e-commerce company was struggling to make sense of their customer purchase history. The dataset was a behemoth, sprawled across multiple spreadsheets, with entries that seemed to defy logic and reason. It was as if the data had a life of its own, taunting me with its inconsistencies and anomalies. My first instinct was to employ the trusty old technique of data profiling. I ran frequency distributions, calculated mean and standard deviations, and even created a few scatter plots to visualize the relationships between variables. But as I delved deeper, I realized that the data was hiding its secrets beneath a layer of noise and inconsistencies. That's when I turned to data scrubbing. I began by identifying and correcting errors in data entry, reconciling mismatched records, and filling in gaps where data was missing. It was a painstaking process, but one that yielded tangible results. With each iteration, the data began to take shape, revealing patterns and correlations that had previously been obscured. However, as I continued to scrub and refine, I encountered a new challenge: data redundancy. Duplicates and near-duplicates were plaguing the dataset, making it difficult to accurately analyze customer behavior. That's when I turned to data transformation, employing techniques like aggregation and grouping to distill the data down to its essence. But even after transformation, the data still had its quirks. That's when I employed data quality rules, implementing checks and balances to ensure that the data conformed to specific standards and formatting. It was a delicate balance, one that required a deep understanding of the business context and the nuances of the data itself. As I worked through the various data cleaning techniques, I began to realize that each one was not a standalone solution, but rather a thread in a larger tapestry. Data profiling informed data scrubbing, which in turn informed data transformation, and so on. It was an iterative process, one that required patience, persistence, and a willingness to adapt. Throughout the process, I found myself oscillating between moments of frustration and flashes of insight. There were times when the data seemed to be working against me, hiding its secrets behind a veil of complexity. But there were also moments of triumph, when a particularly thorny problem was solved, and the data suddenly came alive with meaning. In the end, the e-commerce company was able to leverage the cleaned and refined data to inform their marketing strategies, improve customer retention, and drive revenue growth. It was a testament to the power of operational excellence and the importance of data cleaning techniques in unlocking the full potential of an organization's data. As I look back on that project, I'm reminded that data cleaning is not just a technical exercise, but a deeply human one. It requires empathy, creativity, and a willingness to navigate the messy, the complex, and the unknown. And it's in those moments of uncertainty, when the data seems inscrutable, that we discover the true value of our craft. Data cleaning, also known as data cleansing or data scrubbing, is an essential step in the data pre-processing phase of the data science workflow. It involves identifying and correcting errors, inconsistencies, and inaccuracies in a dataset to improve its quality, thereby ensuring that the insights generated from it are reliable and meaningful. In the pursuit of operational excellence, organizations must employ effective data cleaning techniques to maintain high-quality data that drives informed decision-making. Several common data cleaning techniques are employed across various industries, each with its unique applications, strengths, and weaknesses. Some of the most widely used techniques include: 1. Handling missing values. This technique involves identifying and addressing missing or null values in a dataset. Common methods for handling missing values include mean/median imputation, random forest imputation, and listwise deletion. Each method has its strengths, such as preserving the distribution of data in mean/median imputation, and weaknesses, such as introducing bias in listwise deletion. 2. Data normalization. Data normalization involves scaling numeric data to a common range to prevent features with large ranges from dominating the model. Techniques for data normalization include min-max scaling, z-scoring, and log transformation. Min-max scaling is effective for preserving the shape of the original distribution, while z-scoring is useful for removing outliers. 3. Data transformation. Data transformation involves converting data types or formats to make them more suitable for analysis. Techniques for data transformation include encoding categorical variables, log transformation for skewed distributions, and aggregation of data. Encoding categorical variables helps in reducing dimensionality, while log transformation stabilizes variance. 4. Data quality checks. Data quality checks involve identifying and correcting errors, inconsistencies, and inaccuracies in a dataset. Techniques for data quality checks include data profiling, data validation, and data verification. Data profiling helps in identifying missing values and outliers, while data validation ensures that data adheres to a set of rules or constraints. 5. Data standardization. Data standardization involves converting data into a consistent format to facilitate comparison and analysis. Techniques for data standardization include data cleansing, data transformation, and data aggregation. Data cleansing helps in removing duplicates and correcting errors, while data transformation ensures that data is in a consistent format. 6. Dealing with outliers. Outliers are data points that significantly deviate from the rest of the data. Techniques for dealing with outliers include winsorization, data transformation, and outlier detection algorithms. Winsorization helps in reducing the impact of outliers, while data transformation stabilizes variance. 7. Data aggregation. Data aggregation involves combining multiple data sources or aggregating data to a higher level. Techniques for data aggregation include roll-up, drill-down, and grouping. Roll-up helps in aggregating data to a higher level, while drill-down enables analyzing data at a more detailed level. 8. Data merging and joining. Data merging and joining involve combining multiple data sources into a single data set. Techniques for data merging and joining include inner join, outer join, and union. Inner join helps in combining data based on a common column, while outer join preserves all data from both datasets. 9. Data quality metrics. Data quality metrics involve measuring the quality of a dataset. Techniques for data quality metrics include data accuracy, data completeness, and data consistency. Data accuracy ensures that data is correct, while data completeness measures the proportion of missing values. 10. Automated data cleaning. Automated data cleaning involves using algorithms and tools to identify and correct errors, inconsistencies, and inaccuracies in a dataset. Techniques for automated data cleaning include machine learning algorithms, data quality rules, and data validation checks. Machine learning algorithms help in identifying complex patterns, while data quality rules ensure that data adheres to a set of rules or constraints. In conclusion, each data cleaning technique has its unique applications, strengths and weaknesses, and organizations must carefully select the most appropriate technique based on the specific requirements of their dataset and the goals of their analysis. By employing these techniques effectively, organizations can maintain high-quality data that drives informed decision-making and facilitates operational excellence.